So far I have discussed the psychometric properties that you need for technical adequacy and measurement. And then I talked about cognitive and non-cognitive types of measurement. And finally, I'm going to talk about some more kinds of measurements, specifically questionnaires and interviews, observations. So we'll get started with that. Questionnaires are tools that simply ask questions and have people put in their answers. They can be open-ended or closed. I'll show you some examples of those in a minute. And when you're thinking about using a questionnaire or you're critiquing the use of a questionnaire, there are some things to consider. First of all, has the person developed a valid tool that's really measuring what you think it is? It sounds easy to do, but it's hard to substantiate, and I've talked a lot about validity here. It's always best, excuse me, to use a questionnaire that's already been validated. Sometimes you can even start with an existing questionnaire and then tweak it a little bit. And questionnaires and surveys are easy to find. Most researchers share their tools, and often they're in the appendix of an article. You also need to question whether a questionnaire or a survey is the best way to go. For example, if I want to study student behaviors in a classroom, actually observing their behaviors is probably a more valid measurement than asking them questions about their behaviors. But if I want to know why they behaved as they did, I probably need to ask them with some kind of survey or questionnaire. If you decide to develop your own, you always start by listing out the actual constructs and their components that you really want to measure. An example, if I want to measure, if I want subjects to answer questions about home influences on their homework completion, I have to think about all the components to ask questions about. I have to think of all the different influences that could happen at home: parents, siblings, grandparents, the coach for the soccer league after school, books in the home, access to the internet. And it's very difficult to list all of the influences that could be grouped that way so that I can ask good questions about them. But I have to do that up front. After the questions are developed, it's really important to try out the questionnaire or find some statement in the article that there was a pilot of some kind done. Trying it out ahead of time or pre-testing it actually gives feedback about the clarity, the readability, those sorts of things. Sometimes you find that the answers you get back are so far off the mark that you realize you didn't even ask what you thought you were asking in that question. It's like, what in the world was I really asking to get those kind of answers? Questionnaires and surveys can have open or closed answers or both. Open answers are what we call the ones where people have to write it in. So I gave you an example there. What was the strategy you learned today in math class? And then the students would have to write their answers in. Closed answers are when people choose an answer from a list or a scale. You can actually mix the two on your instrument, but most people find that irritating. If you're going to mix both kinds, then keep them in sections, and that will help a little bit. Questionnaire, I'm using the word questionnaires, but it's often called a survey, and sometimes it's called an inventory, especially if it's an inventory of people's beliefs or personality traits or something like that. Scales are often the answer that people give. They're often scaled, and these are really valuable because they let us then code the data accurately. And there are 4 common types of scales that I'm going to talk to you about. Let's start with the Likert scale. A Likert scale is when you give a stem or a statement. You can see I've marked it in red there. The stem for this one is the professional development session was paced appropriately. So I then want to have a scale of the extent of the agreement or feeling about that statement from my respondents. So I give them a choice in what's called the response continuum, and I've marked that in red down below. You can provide an odd number of options, as I did on the left, and that lets people choose a neutral response. Or you can choose an even number of responses, and then they have to be in one end or the other of the continuum. Usually, no one seems to agree on the best way. You really have to think this through on how you want to do this. People tend to go for the middle if you give them a neutral. And yet if you don't give them a neutral, you may be actually missing out if somebody really truly has a neutral position on something. And you don't want to miss that. So you could eliminate answers or data that way. Usually the stem represents an extreme, so that you want people to either agree or disagree with that statement. So the statement has to lend itself to that. But there are examples that don't do this, but they're not common. On one survey that I'm using right now, we ask the students whether they have a mobile device given to them by the school. And then the continuum of their answers ranges from yes, and I can take it home every day. Yes, but I can only take it home sometimes. Yes, but I cannot take it home. And then no, I do not have a school device. So instead of asking for their agreement or their preference along the scale, it's asking them which of those options applies most to them. There's a scale where we use a semantic differential. And when you set up a semantic differential survey, what you do is you put down a stem that's usually very short, and then you choose two opposite adjectives about that short stem. And then the respondents actually put in like an X along the continuum as to where they are. So the first example there, my teacher is, and then you've got fair on one side and unfair on the total opposite, and they can rate along that in between the two of them. This class is interesting or boring, and so they have to put where they fall along that continuum. You don't see these as often in research, but they could be really, really powerful. Checklists are very common, and there's two ways to do a checklist. And the one, it's almost like multiple choice. You just simply give them a statement, and then they choose their answer or what applies to them. And then they're choosing the best or the one that applies. And these, the example I gave there is your current marital status is, and then you have to choose one of those choices. Now, you can also do a checklist where you have the person choose all that apply to them or that they feel strongly about. And I apologize for these goofy bullets not being lined up. But in this case, I'm trying to get the person's, the ethnicities that they identify with. And in today's world, it's always not one box. And so in this question, a person can choose as many as they that apply to them. Ranked items are really common too in research. And this is when you give respondents a list of items or beliefs or constructs, and then you have them rank them according to their preferences or the importance to them or an action they think should be taken. So the example I gave you would be from if we needed to gather data about which programs to fund. And we've got these 5 choices, and I want my respondents to rank them from 1, least or most important, to 5, not very important at all. And so you could actually have another choice for them that was other, and they would have to write it in. But if you know what the choices are, you just limit them and they have to rank them for you. Very valuable stuff. Making a good questionnaire or survey is a lot like making a good test. It's tough. So you want some things to consider. You want to make sure that the type of question goes with the type of response that you need. So a good one would be if I'm asking somebody their current marital status, I don't need check all that apply. They're married or they're single, never been married, or divorced or widowed. There's usually not both unless something unusual is going on. The items need to be really clear and specific. Having children respond to a statement on a Likert scale of "my teacher is good," those responses are going to be all over the place. It's not really going to give you a way to validly interpret good. That could mean a lot of different things to a lot of different children. There should just be one idea per question. No double-barreled questions. So a question, and you've probably run into this on surveys, and it's really irritating. If you get asked to how you agree with a statement like, my school administrator listens to me and evaluates me fairly. Okay, maybe I want to agree with that the administrator listens to me, but I disagree on the fairness of my evaluation. How am I going to answer that question? So always look for and in there. The literacy level, you have to know a bit about the subjects you're going to give your survey to. But if it's going to be widely used, keep the literacy level at about between 6th and 8th grade is a good rule of thumb. You don't want to offend people. You don't want to turn people off. You don't want to have people confused with the vocabulary that you use. Make it relevant to your participants. There's a reason that those participants are taking this survey, so make it worthwhile that they're giving you the time. Keep the length in mind. You run into people just won't complete it if it's too long, if it's going to take up too much of their time. You've probably heard the adage to avoid negative wording. It's best to state things in a positive way and then have people agree or disagree. You need to be careful that your wording doesn't elicit some kind of strong emotion in people unless you are trying to bring up controversy. So you need to stay away from words that are loaded or controversial unless that's actually what you're trying to do. And you need to avoid leading questions. I've taken surveys where I go, oh my gosh, this is so obvious what they are trying to get out of me, and it kind of ticks me off sometimes that they're leading me a certain way. So be careful that your questions don't do that. Now, besides questionnaires and surveys and inventories, we've got other types of tools that you will see often in research. Interviews. A lot of the articles that you're looking at that you turned in when you turned in your 5-article list involved observations and interviews. So let's talk about those a minute. I can use interviews to find out information about people very effectively. And a lot of people think that this is just in qualitative research, but we're talking quantitative now. There are very powerful ways that I can pull information out of interviews and put a numerical value to it and run some analyses. Interviews can be either structured or unstructured, and that means that if it's structured, I've got a predetermined pattern and questions I'm going to ask. If it's unstructured, it's going to be more loose and it's going to flow and sound more like a conversation, and I'm going to let the person I'm interviewing lead the conversation. In quantitative research, the interviews are usually more structured. You can imagine you could actually give a questionnaire or a survey with an interview with questions. And what we find is that when you actually ask people questions in a conversation experience, they tend to usually build a rapport with you, and they're more motivated to answer your questions. You can actually probe a little bit. If someone's answer isn't quite clear, if their answer is not quite clear, you could ask for clarification, or what did you mean by that? Or give me an example, and probe a little more. So an interview can be very flexible in what you ask and can get out of the respondents. The same things that come up on some of the other non-cognitive measures are huge ways to introduce error. When you're interviewing someone face-to-face, there is a real strong opportunity for error with social acceptability. People are more likely to give you an honest answer on a survey than they probably are face-to-face in an interview where they're worried about what you might think about them right there as you're sitting there. Interviews can be very time consuming and expensive to code, but what you do for quantitative research is you go in and you code their answers and their responses. And of course, we want to turn those into some kind of numbers that we can run analyses on. They can be very hard to score. The interviewer needs to be very skilled and very trained at doing this. And you have to be very aware of the interviewer's role in all of this. Am I going to interview and be really part of the process, or am I going to sit back with a clipboard and just record your answers? The interviewer becomes a very subjective part of the process, and of course a source of possible error. So with an interview, the sources of error you need to look for as the interview is described in your articles. You're going to be looking for interviewer bias, especially with a convenience sample. Did the interviewer go in there with preconceived ideas about the group or their capabilities or their abilities? What is there any kind of clouding or leading that they're doing? And the interviewer characteristics, you have to look at those as you look at the transcript of the interview, and see how much the interviewer really inserts him or herself. Actually conducting the interview can be a source of error. Grabbing somebody in the hall, quick, have you got 5 minutes? Let me ask you these questions quick before the bell rings. I mean, that's obviously going to introduce a lot of error. And then there's error in the coding. And if you've got multiple people coding and multiple people interviewing, they have got to come to some kind of agreement, again, with inter-rater reliability types of things about what they are actually going to code in the interviews. Now, observations are a little different than interviews because you're not usually asking questions. You're usually recording. I'm going to go back to interviews for just a minute. Whether you're recording the interview or not really seems to make a difference with the person, with the respondent. Some people will be very comfortable. Do you mind if I record this? And you push record. And others are very uncomfortable having their answers recorded. They won't. It just totally depends on the person. So all of that needs to be determined ahead of time with your subjects. Are you willing to do this? And please know that it's going to be recorded. Now, going back to observations. Observations happen all the time in educational research, and you'll see a lot of this in the studies that you're going to be critiquing. Observations can happen in either a natural or a controlled setting. So I can go into a classroom and observe in that setting that the children are used to, or I could bring the children into a lab and observe them. In a controlled setting, we can actually hide the observer, and the children may not even know that they're being observed, or they may sense that they're being observed, but they can't see the person or the clipboard or what's being done. So it just depends on what your purposes are, so that your observations can be validly interpreted. Observations can be structured or unstructured, and I'm sure that you can make the leap that in quantitative research, we want to use our observations as structured as we possibly can. We want to know what kinds of things we're going to look for and how we're going to look for it, and pre-test and get the observers all on the same page before we march into those classrooms. When you're doing observations, you have to consider the role of the observer. Is the observer going to be detached? And that's what we call a complete observer. They're going to sit there. They're not going to interact at all with the subjects. They may even be behind a window or some other way. They may be watching a videotape of something that's happened, so that they are not part of the action in the lab or the classroom where the observations are happening. And then you can have observations where the observers are much more involved. And I think of sometimes when supervisors come in classrooms to observe teachers, some supervisors are very comfortable asking kids questions and joining in with I remember once being observed, and And I turned around and the principal was doing a lab with a group of kids. She just jumped right in and joined them. And so there's different styles that way. And if you're going to validly interpret the results, you need to know what kind of observer was in the classroom or in the setting. Now the observers are making inferences. When they're writing things down, detached or involved is a different construct. Now I'm talking about the inferences that they're making. If I'm observing and I make low inferences, I'm recording things like 3 children got out of their seats at 11:05. They were out of their seats for 2 minutes. The teacher used a set of manipulatives with group 3 and gave them verbal instructions. Those, I'm not interpreting or predicting or any kind of judgment call on what's happening in the classroom. High inferences, though, are when I'm writing down things like the children seemed happy. The teacher taught the lesson effectively. That's the other end of the scale where all of what I'm recording is basically an inference that I've made about what I've seen. Now that's something that's harder to do. Imagine that I'm sitting in a classroom and I'm watching a child in the 3rd row, middle of the 3rd row, and she's twirling her hair around her finger. I could make the inference that she's bored. I could make an inference that she's not paying attention. I could make an inference that this is a child whose hands have to be busy all the time, so she's got this habit of twirling her hair. I could make all kinds of inferences about that one behavior. So if I'm going to go with low inference when I'm observing, and this is what we suggest, especially for quantitative research where we're not trying to interject the why into the actual observation. We keep it on the low end, and I would write down that the Mary in the 3rd row, in the middle of the 3rd row, twirled her hair around her finger, and as opposed to making a judgment or an inference about why she was doing it. So when we do structured observations in quantitative research, there's 5 that are really common. You'll find that the observer goes in and can just do frequency counts. I'm studying children who speak out without raising their hand. And so I go in for 20 minutes in this classroom and I count the number of times that happens. Now, a duration observation is a little bit different. When I'm looking at the duration of something, I'm saying that in these 5 minutes, or how long a behavior lasts, I'm going to say, that this lasts, I'm looking for these behaviors, and then I'm going to record how long they lasted. Interval structures mean that I'm looking for all the behaviors of a particular person at intervals. So I'm going to look for 5 minutes. I'm going to record everything Joseph does. Absolutely everything I can get down for 5 minutes. Now, continuous means that I'm going to look at the behaviors of a group or a small group of students for, say, 10 minutes. And I'm going to write down everything I can see. Time sampling means that I'm actually, every 5 minutes, I'm going to glance around and see who is or what behaviors are happening that I'm looking for. I'm not going to write them down for 5 minutes, just every 5 minutes on the 5 minutes. I'm going to look around the room and record what's happening. So that's a time sampling. You don't need to know the differences in all these, but know that when you read your articles, you're going to read about the observations that were done, and the person will say, I did a continuous observation, or I did a frequency count or a tally, and that's a very common one too in quantitative research. In observations, there are obviously sources of error. I've talked about the observer bias. If, for example, if I'm observing a classroom and the last time I went in there to observe, it was fantastic. Everybody was on task. The teacher was just on point that day and things were working. The next time that I go in there, I'm going to very likely go in expecting that of the classroom. Now, contamination is when I'm going in to observe something and I know why I'm going in there and I know what the study's about and I know what I'm trying to find. And so there's the possibility of contamination. I have some observers who go into classrooms in one project I'm working with, and they use an observation protocol that's more like a checklist actually, and they're looking for how the classroom is changing as technology gets used. They know darn well what they're looking for, and they hunt for those kinds of behaviors in every teacher's classroom. It's just hilarious to watch what they do with that tool. I saw a little bit of this, so I'm going to record that I saw it. That's called contamination, and in the study I'm doing, it's fine. It's not going to, that kind of error is not going to cause problems. The halo effect is when when I start to see things because I've seen them before, or my initial ratings were kind of scary, so they can only go up from there. They couldn't go down, kind of thing. Those are the halo effect. So we control for this kind of error with training the observers, with multiple observers who have to agree. And in some studies, it's so important that you make your observers actually blind. They don't know why they're going in there and making these observations. They don't know anything about the study. So we call that making them blind and sending them in, if possible. So for some, it might be a real need depending on how the study is going to be used. So I've talked a lot in this lecture about collecting data. And now I'd like to kind of bring it down to what you're going to need to do. You're going to be critiquing these articles or these research studies. I want you to be a healthy consumer of research. So think back about validity evidence and what I talked about there, and whether the tool is really measuring what it says it measures, and so you can make inferences that are appropriate. The reliability evidence that you've got, whether it's consistently measuring what it says it's measuring. You need to look for a description of the instrument. Unless it's something well known like the Stanford-Binet IQ test or the Briggs-Meyer personality inventory, things like that, there ought to be a description of that instrument, where they got it, how they developed it, all of that, and then how it was administered. Look for, if it's some kind of test, look for whether it's normed, and the norming information that's used. You know, the mean of the group was 120, and the standard deviation from that. Those are norming kinds of terms. Or look for the criterion for their categories. Meets standard cutoff point was a score of 275 as a raw score. And then remember too, if they're normed, you may be looking at z-scores in charts for students so that they can be ranked or lined up along some kind of interval scale. Look for meaningful scores and interpretations, and that's where things like z-scores help. It's not meaningful to compare different tests with different scales, and so we need that standardized score. When you're looking at some of the tools like observers and interviews, look at see if they report a participation rate for their survey. If it's really low, they're missing valuable information. Look at what was done to train or norm the observers and the inferences that they're expected to make in their observations. And then, last of all, look for the role of that observer or the interviewer. How much do they have to do? with the actual process and how much error could be involved in that. And that gives you a pretty good summary of how to critique this part of a research article.